So, hello everyone. My name is Shubham Tiwari, and I am the group leader of Team CodeXccelrate. I am from Lokmanya Tilak College of Engineering, Koparkhairane, Navi Mumbai, Maharashtra. Uh, so, Yeah. So our problem statement title is from Ministry of AYUSH, having problem statement code SIH1343. So that is identification of different medicinal plants, raw materials through image processing using machine learning algorithms. So I mean, what is basically this problem statement defines? So it defines to there are like larger species of medicinal plants and raw materials out there, and it is so hard to identify them for the common user. So basically, who is not a practitioner in that field, basically who is not a herbalist, but who is not a pharmacist. Basically, I'm doing engineering, and it is not quite good for me to identify that what species of this medicinal plant belongs to. So that is why this is important. It is not, it is one of the thing, and there can be a lot of thing that basically needs in medicinal in medicines that we need to identify and work faster for the greater good, for the I can say scalability in making the medicines. So what our software what software we offering is basically we are providing a front end, mobile front end, web front end, in which there will be separate columns, like separate buttons will be there for home, about us sections, and contact us section, and feedback section, and maintenance section, and there will be a login section in which user can log in or register through their Google mail IDs or email IDs that they are providing. So that authentication will be done by Firebase, basically in database. So that we'll be using a Firebase for database and also for the Google authentication. So what is basically happening here when the UI comes to the user? So when they log in, so what will happen if that there will be a prompt basically there will be blocks that it will be learned that will be updated on daily basis, that this is a, did you know this, and all. And there will be a search section in which they will be asked to give an image as an input to identify like what if they want to find that what species of this plant is. So they'll be inputting the uh, leaf image, and that image should be in like in high resolution, as the data set we are training our model is basically is trained on basically large resolution images. So it is basically needed for the users to give the images in large sizes, as it will be not as it will be harder for the deep learning models to convert them into bytes, and there will be outliers for them that they will be generating wrong predictions as the images won't be high resolution. So what happens is whenever they input the images goes to AWS S3 bucket, as it is a uh, uh, temporary cloud storage, and there will be there the images will be stored for temporary basis, and then it will be sent for backend. Basically, how and where the models will be getting the images is here. So the AWS S3 bucket gives the images as an input to temporary database, in which the deep learning model converts them into bytes. And what happens afterwards? So basically, how deep learning models are trained basically first. So this is a this is a large data set. As you can see, here are labels given. As you can see, asthma plants. So what is this? It is a label given for this leaf. So whenever this leaf will be given as an input, as you can see, here are another images of the same species of plant, that is asthma plant. So whenever these whenever these images are given as an input, the model will basically just do that as a asthma plant. So what is the label for these leaves? It is asthma plant. So it will gives an value that is asthma plant as a prediction. So I did a prediction of species of that particular inputted plant species from the user. So what we done here, so then there will be an if and else condition, that if the if the model is finds the species, so that will be then the model will update the AWS S3 bucket that this is the species, and it also gives, and it will also filter the species to Wikipedia API. There will be an API call for that, as we will be inquiring the information of that particular species from Wikipedia API, as when the model finds that this plant that is inputted, it is given as an input from the user, is belongs to this species. So then that model will be, send the species information to Wikipedia API to search about that species, if that species is endangered, like in what environments that these plants are found, and in what regions they are found. So it will be stored in plants information temporary database. So what will happen is then uh, all this information will be sent to AWS S3 bucket after the prediction, and after the fetching the information from Wikipedia using API calls. So it will be sent to AWS S3 bucket for the output generation to the user. So when the plant information contains the location, there will we will be using APIs, mapping APIs, Google Maps API. So what will Google Map API do basically? So we have fetched the location from the Wikipedia, as how in what regions this do these plants are found. So it will be sent to the um Google Maps API to mark them and show them as an output to the user. So user can be anyone, like basically a consumer, or even a practitioner in herbalist. So this is the front end and back end part. So now we'll be coming to the deep learning models. So how deep learning model will do? How deep learning model will predict? So there will be image data set for plant species, that as I showed you earlier. Wait, let me move myself. Yeah. So here you can see there are asthma plants, and there are many other species of them. Many other species, uh, you can say Indian stinging nettle, yes, and all this. So if the so all this will be trained, will be doing pre-processing on them, and will be removing outliers, as it is not necessary that what all the images are belongs to the same species. So we'll be removing them, and also we will removing null values, as such as there can be in some folder of this data set, there can be a leaf, sorry, other than leaf. So that can be a tree, or that can be a flower. So we will be removing all them, as they we don't need them. We only need leaves to predict. So after that pre-processing, we'll be training and validating the model. So basically, we will be training on the large size of the data set basically, and then then the model will be trained on that, and then we'll be fine tuning the model by testing it on the testing sets. So all this will be done, and then we will be fine tuning the model even after the testing sets are come less accurate. So what we'll be doing is then we'll be deploying the model on the backend for the prediction, for the further predictions. So here are the technology stacks. We will be using React and Tailwind CSS for the front end, and Figma for the designing the front end. So Python, NumPy, and Pandas will be used for pre-processing and labeling, as it is important for this folder to have this label. As you can see here, this folder has this label. So all these images will have a same label, but as yes. So see here, these are the outliers. As you can see, as I was telling earlier, these are the outliers. We don't need them basically. These can cause our deep learning model to be less accurate, as we will be removing all them. So that part will be coming in here, pre-processing. So after that, we will be using OpenCV and TensorFlow for image processing and deep learning. So Node.js and Django. Node.js will be used for server-side rendering, and Django will be used for ML integration to the front end, that is React. So and MongoDB will be used for storing the data, basically what images the user have searched till now. All that will be stored in MongoDB storage, and Firebase will be used for Google authentication. So that is what in a nutshell our project is. Basically, our solution to this problem statement is. So as I told you earlier, basically API integration all will be done for Wikipedia API and for Google Map APIs, and we'll also be using upscaling images APIs for several AIs out there that will help user to upscale their images basically. So temporary data storage as AWS S3 bucket. They are slow, but they are consistent, as they provide unlimited amount of storage that you want for the temporary storage. So and database management, as I told you, MongoDB will be used for users all. Sorry. And these are the showstopper basically. So these things can like basically maximize the output. So it is not asked in the problem statement, but we still are providing geographical mapping, because I think it is a great thing for farmers and for medicine experts out there. And we will be also be hosting this project on cloud platforms like Google Cloud and AWS, or AWS, not and AWS, but it was or AWS. So it will be the basically the software that we are building. It will be having the cross platform compatibility, as it can run on as it as the web app will can run on any type of devices that are out there in the market. Can run on any type of viewport height device can have, and that's it. And the most important thing is that we will be upscaling and scaling this will be in business growth as well, as the industries out there, such as chemical industries and organization, that they need for such software to identify many type of herbs, and you can say and all things. So that's what in a nutshell our project is. As told you earlier, all these points. So yeah. So my name is Shubham Tiwari, and my team members are Praveen Singh, Ajay Gupta, Ashutosh Singh, Ragini Kaushal Kishore, Rigved Dalvi, and our mentors are first mentor is Professor Jayendra Jadhav sir, and he has expertise in blockchain, and he has a domain experience as he has blockchain's experience for 4 to 5 years, and the second mentor is Professor Rajendra Goli sir, and he has expertise in AIML domain, and for about 2 to 3 years, and they have the academic knowledge more than 2 to 3 years. So, bus and that is it. And thank you so much. And if you like the solution, tell me in comments. Thank you.